Hi everyone. Today we're going to be running a gel electrophoresis in order to study STRs to solve a mystery. Now, the first thing that I did before I even started the camera was to spray everything down with a 70% ethanol solution. The lab today is a little technical and uses DNA and enzymes that are easily contaminated, and we don't want contamination or else our mystery won't turn out the way it should. So I sprayed everything down to try to limit the potential for contamination. There are a few things on the lab bench today. The first thing that I want to show you are our micropipetters. We used these early in the semester, and just a quick refresher of how they work. These are meant to pick up very precise amounts of liquids in pretty small amounts in most cases. So on the side, tells you how much this is set to pick up. So this is in microliters, and it's set to pick up 5 microliters. So we can change that within the range of the micropipetter a little bit by twisting the top. In order to pick something up, to get a liquid, we need my pipette tips. Just jam the pipetter into the tip. Push the button down until you get some resistance at the first stop. Put it into a liquid. This is just water, just for a demonstration. Release the button, pull it out, and whatever you're dispensing that water into for the liquid, push the button to the first stop and then all the way down until you can't push it down any further. And then sometimes you might need to dab aside of whatever you're doing just to get rid of it. This I'm just using as a waste container, and we want to make sure that we use a clean pipette tip every single time. This button right here ejects the tip right into the waste. So that's all we need for pipette. Other things that we have around on our lab bench are our DNA samples. So I have 18 of these tubes, each with a different DNA sample. I will post or give to your teachers to post this list right here that tells you what each sample is in case you need to refer to it during your lab or during your worksheet. And these were all collected from our crime scene. All 18 samples came from different sources so that we can match up STRs when we're done running our electrophoresis and compare them. We also have enzyme, and this enzyme is the restriction enzyme that's going to be cutting the STRs out of our DNA so that we can compare them. We have deionized water, and we have ladder, and I'll talk about ladder once I'm loading it into the gel, but our ladder is basically just a scale. It's a comparison on our gel so that we can see the weights of what our different STRs end up being. So the first thing our instructions tell us to do is to take each of our DNA samples and add enzyme into each one. So I'm going to take all 18 of these, all 18 of our DNA samples from our crime scene, and I'm going to add 5 milliliters of enzyme, the restriction enzyme that's going to cut those DNA samples. And then I'm going to add 12 microliters of deionized water into each sample, all 18 samples. And then I'm going to put all 18 samples into the incubator for 10 to 12 minutes at 37 degrees Celsius. So I'm going to show you loading the first probably 2 DNA samples just to give you the example, just to show you what it's looking like. So I have my micropipetter, and I need 5 microliters of enzyme. This is already set to 5 microliters. I have my enzyme. Still a little frozen, so I'm going to try to thaw that out a little bit. It came out of our freezer. And remember, I want to depress the button down to the first stop. put it into the microtubule, and then release the button and pull it out. So that's my 5 microliters of restriction enzyme. I doubt you can see it in the video, but it's a very, very small amount inside of that tip. You can just barely see it in there. And then I'm going to put it in our DNA sample 1, going down to the first stop, down to the second stop, all the way down. Get it in there. Get rid of my tip. Now I need 12 microliters of water, deionized water. This one is already set to 12 microliters. Just grab a different micropipetter. Again, if I need to change it, then I would turn the knob. 12 microliters. Get a different tip. Grab my 12 microliters out by pressing the button down to the first stop, into the water, and then releasing. Then I'm also going to put this into my first DNA sample. And the sample's done. So I'm going to repeat that through all 18 samples. I'm not going to record that so that you don't have to sit there and watch me repeat this 18 times. And then we're going to put them all in the incubator. Okay, so I have mixed all of our enzymes and DNAs and water. So each one of these microtubules has our DNA sample in them, 1 through 18. And again, I've added 5 microliters of restriction enzyme and 12 microliters of deionized water. I'm going to flick each one just to mix it and put each one into one of these little trays. I'm going to do this quickly so that you're not sitting here watching me do it. And this does a few things. For one, it mixes the DNA, enzyme, and water. It also helps get all of the liquids down to the bottom of that tubule a little bit. We can use a centrifuge, and I'll do that after I've incubated. But in the short term, this is a decent mixing strategy. And the reason why I'm separating these into separate trays is because we have samples 1 through 9 at our first loci and samples 10 through 18 in our second loci. Here we go, 18. 10 through 18 in our second loci. Now our incubator is set at 37 degrees Celsius. It's not quite there yet, but this is okay. This is high enough for our purposes. And I'll just put this in here and let them incubate for 10 to 12 minutes. Since it's not quite at 37, I'm probably going to give it that whole 12-minute range. Well, while our samples are incubating, I'm going to show you the agarose gels. They've been stored they were poured yesterday and stored in the fridge overnight. And this is basically just a medium for the samples to run through. And we electrify the gels and the samples, and while they're running, we'll actually see them moving down this gel. If you look, I'm hoping you can see these on the video, there's little notches all along the top of the gel, and that's where we're going to load our samples. I'm going to put these into the gel chambers. Again, one of these is for the loci 1 samples, and the other one is for loci 2 samples. And I'm going to load the latter into both of these gels. Now again, I'm going to take my micropipetter, and I am putting 6 microliters of the latter into each gel. Getting a new pipette tip, and the ladder, and again the ladder is basically our control. This is what we're using to compare the sizes of our STRs to. This is a little easier to see in there than the other things, than the water was. So you can actually see the dye in the tip of the pipette. Now this is a very very small stuff going on here, and it's easy to screw it up. So when you're doing this, I'll make another video of a top-down view that's a little easier to see it. But we have these little wells in the gel, and we want to just get our micropipette tip into that well, dispense our liquid into it, and release, and pull out and release. And I'm going to do that one more time with the other one. And you can see as I'm doing this, I'm putting both elbows on the table, both hands on the micropipetter, and that's just to make sure that I am as stable as possible as I do this. Just making sure that was in there right. And that's all. That's all there is to it. So it's a fairly delicate procedure. It's easy to lose your sample into the buffer or poke a hole through the bottom of the gel. So bracing yourself is sort of important during doing that. All right, we've hit our 12 minutes. I'm going to pull our samples out of their water bath. And the last thing that we're going to do before we load them in the gel is just to add sample buffer to each sample. So the sample buffer kind of serves two purposes. The first is to provide a dye. So it makes it so that we can see our sample as it runs through the gel. And the second is that it weighs it down so that when we put it into the liquid, the buffer in the electrophoresis chamber, that it actually sinks to the bottom of the well. So same exact thing that I did before. I'm going to take a micropipetter. Sorry, I didn't have one ready this time. I'm going to take a micropipetter. I'm going to set it to one microliter. And I'm going to take the sample buffer and add 1 microliter of sample buffer into each sample. And same thing I did before. I'm going to use a different tip every single time. So I take the sample buffer, and it's just a very small push at this point because 1 microliter is a very, very small amount. So we have just a tiny bit of sample buffer in here, and I'm going to add it individually to each sample, just like I did with the enzyme. And same thing as I did before, I'm going to flick it to get that all mixed in well. So every single time, getting a new pipette tip. Go down to the first stop, put it in the liquid, let go, pull it out, and all the way down to the second stop. This is a centrifuge. We're going to put each one in here really quickly, each sample. Whenever you use a centrifuge, you want to make sure that it is balanced. We have an even number of samples, so it's not that big of a deal, but if you're only doing one thing and you're putting it on one side, you want to make sure that on the other side you have perfectly opposite of it another sample of the same size, or even just a tube with water in it. Just needs to run for a second, and it's really just to get all of those liquids and all down to the bottom of the tubules, just so that they're well mixed and easy to pipette out. And so just comparing, this one has stuff just spread all over it, and the number one, everything's nice and at the bottom and will be easy to work with. So just really quickly, just to get everything in an easy spot for us to grab. So this is our gel electrophoresis, a little closer than what I had shown it to you before. You can see, let me grab a tip. You can see at the top of that gel the little well chambers. So I'll just grab a tip and point to them. So these little slots are where each sample is going to end up going. This one on the very end is the one that I've already added the ladder to. And same thing with the other gel chamber. Okay. So just because I was touching stuff, I'm going to get another tip. Now this is set to 6 microliters. And I'm going to take 6 microliters of each of our samples and put them into their designated wells. So just to make sure that we can keep everything straight, this is sample 1, and it's going to go in the first well. Made a little bit of a mess, but most of the sample got in that well. Now you can see that that has some in it. I'm going to get a new tip, and I'm going to put sample 2 into that second well. And you can't see it, but I'm doing the same thing that I did before. I have both elbows on the table, and I'm bracing myself so that I can get those samples into their well accurately. Now I'm going to run through this for all 18 samples. 9 are going to go in this chamber, 10 through 18 are going to go in the other chamber, and then I'll post a quick video of hooking them up and what it looks like while they're running. So now we have our loaded gel electrophoresis chambers. I'll try to bring it around a little bit and show you what they look like from up top. And you can see each of the wells has a sample sitting in it. Now all we have to do to finish up this experiment is to hook each one up and run electricity through it. And now that is on, and they will, the samples will start to run down the gels, and I'll post a picture more than likely, rather than a video of what they'll look like when they're done, just because video is not really going to show it very well. But I'll post pictures of the completed gels after the samples have run. But I do kind of want to show you what these look like while they're running. So this is running electricity through the chamber and drawing those samples down. You can see little bubbles coming up from the bottom of the chamber to the top. Even on my phone I can see it, so I'm hoping it shows up in the video. And once they are done, they will be able to be used to solve our mystery. You'll be able to compare those, the samples found at the crime scene to the samples found, taken from our suspects, and should be able to draw some conclusions. Just to show what this looks like while it's running, you can see the wells at the very top where we loaded our samples, and then the short tandem repeats just drop out based on their weight as they move through the gel. So this blue and this purple are going to continue moving down until they start to separate, and we can see the differences between the sizes of our repeats. Email your instructor if you have any questions or run into any issues. If you're stuck and need some guidance, that's what they are there for, so shoot them an email. As a reminder, don't wait until the very last minute. Give them time to respond to your email and you time to get that response and work through it. Our teachers are not checking their emails 24/7, so make sure that you give a little bit of leeway there. This worksheet is due at the end of the day on Friday, so again, make sure you leave yourself enough time to do it and get that into your instructor however they've told you to submit. But if there's anything that is unclear or anything that you feel like you need more information on, again, reach out to your instructor and ask them for more details on what this procedure was or how it was run so that you can finish your worksheet. As always, stay healthy, keep washing your hands, keep social distancing, all that fun stuff. Take care, guys.